Gold. Just the word itself sounds expensive, doesn't it? It glimmers, it shines. For thousands of years, humans have been completely fascinated by this incredible metal. It doesn't rust or tarnish, it's rare, and it's heavy. A piece of gold the size of your mobile phone would weigh as much as a big bag of sugar. This amazing stuff has been used to make crowns for kings, beautiful jewelry for queens, and even sacred objects for ancient temples. It's a symbol of power, wealth, and eternal beauty. People have sailed across oceans, fought wars, and dug deep into the earth, all for a chance to hold this gleaming yellow treasure in their hands. The allure of gold is universal. It's a language everyone understands. You could show a gold coin to someone from ancient Rome or to a modern-day banker, and both would instantly recognize its value. This isn't just because it's pretty, it's because gold is incredibly useful and incredibly scarce. All the gold ever mined in the history of the world could fit into just a few Olympic-sized swimming pools. Think about that. Every ring, every necklace, every gold bar, all fitting into such a small space. This rarity is a huge part of what makes it so valuable, and why the journey of creating a single, perfect gold bar is one of the most protected and fascinating processes on the planet. So, what makes some gold bars more special, more expensive than others? It's not just about the weight, it's about the story behind the bar. It's about purity, so high it's almost unbelievable. It's about the incredible skill and precision that goes into making it. We're talking about a level of perfection that turns a simple block of metal into a work of art, an object of immense desire. These aren't just any old lumps of gold, these are the supercars of the bullion world. They are crafted in super secure facilities where every speck of dust is accounted for, and every step is monitored with military-like precision. Today, we're going on a journey. We're going to pull back the curtain on this secret world. We'll follow the trail of gold from a rugged, dusty mine deep within the earth, all the way to a gleaming, perfect bar sitting inside one of the most secure vaults in the world. Our journey starts deep underground, or sometimes in vast open pits stretching for miles. This is where the hunt for gold begins. Finding gold isn't easy. It's not just lying around in big, shiny nuggets waiting to be picked up, though that does happen very rarely. Most of the time, gold exists as tiny, almost invisible specks trapped inside massive quantities of rock called ore. Geologists, the detectives of the rock world, spend years studying maps and testing soil samples. They use advanced equipment like ground-penetrating radar and magnetometers to search for clues hidden beneath the surface. It's a high-stakes treasure hunt on a gigantic scale. Once a promising spot is found, the real work begins. This is where the big toys come out. Massive drills, some as tall as a house, bore deep into the earth to collect core samples. These long cylinders of rock are carefully analyzed in a lab. Scientists check them for even the tiniest flecks of gold. If the samples show enough gold to be profitable, the mining operation roars to life. This is a crucial step. A mine won't even be built unless they are certain there's enough gold to make the massive investment worthwhile. It can cost billions of dollars and take over a decade just to get a modern gold mine up and running. In an open-pit mine, controlled explosions are used to break apart the rock. Giant shovels capable of scooping up tons of earth in a single bite load the broken ore onto haul trucks. And these aren't your average pickup trucks. These are behemoths, some of the largest vehicles on Earth, with tires taller than 2 people. They trundle along specially built roads carrying their precious cargo to the processing plant. In an underground mine, the process is even more challenging. Miners travel deep into the earth in cages, then drill and blast tunnels through solid rock, following the narrow veins of gold ore, sometimes miles below the surface. Every single truckload of this rock, this ore, is the first step towards making a gold bar. It's hard to believe that the tons of gray, dusty rock rumbling past contain the raw material for something so pure and beautiful. The ratio is mind-boggling. To get enough gold for a single wedding ring, miners might have to dig up and process several tons of ore. For a large investment-grade gold bar, we're talking about a small mountain of rock. The journey from this rough, raw material to a polished, perfect bar is long and complex, and it all starts here, with a bang and a cloud of dust. The giant haul trucks have delivered their cargo, dumping tons of gold-bearing ore into heaps at the processing plant. But the gold is still locked away, a prisoner inside the hard rock. The first step to freeing it is a process of brute force. The ore is fed into a primary crusher, a powerful machine with massive steel jaws. This machine is pure muscle. With immense power, it grips and squeezes the huge boulders, breaking them down into smaller, more manageable rocks about the size of a fist. The noise is incredible, a deafening crunch and groan of metal against stone, but the pieces are still far too big. The microscopic gold particles are still trapped. So, the crushed rock moves along a conveyor belt to the next stage, the grinding mills. The most common type is a SAG, or semi-autogenous grinding mill. Imagine a colossal steel drum as big as a small room lying on its side. The crushed ore is tumbled inside this rotating drum along with large, heavy steel balls. As the mill spins, the rocks and steel balls are lifted up the side and then come crashing down, smashing against each other. This constant, violent action grinds the rock into smaller and smaller particles. From the SAG mill, the material, which now looks like coarse gravel, is mixed with water to create a slurry. This muddy mixture is then pumped into another type of mill, called a ball mill. This machine works on a similar principle to the SAG mill but is designed for finer grinding. It's filled with smaller steel balls and spins faster. The goal here is to grind the slurry until it has the consistency of fine sand or even talcum powder. This step is absolutely critical. The rock must be ground down so finely that the individual microscopic particles of gold are finally exposed, ready for the next stage of extraction. The whole crushing and grinding circuit is a symphony of mechanical power. It's a continuous, noisy, and dusty process overseen by skilled operators in a central control room. They monitor everything on computer screens from the speed of the mills to the size of the particles. They have to get it just right. If the rock isn't ground finely enough, the gold will remain trapped, and the whole operation will be inefficient. If it's ground too much, they waste energy. It's a careful balancing act of immense power and precise control, all to turn a mountain of rock into a river of fine gold-bearing mud. Now that the ore has been ground into a fine powder, the real magic begins. We need a way to separate the tiny gold particles from the vast amount of worthless rock powder they're mixed with. This is done through a clever chemical process, most commonly using a cyanide solution. The fine, watery slurry is pumped into enormous tanks called leaching tanks. Here, a very dilute solution of sodium cyanide is added. This might sound dangerous, and it is, which is why it's handled with extreme care in a highly controlled environment. The cyanide performs a special chemical trick. It dissolves the gold. As the slurry is gently stirred in these massive tanks, the cyanide solution gets to work. It latches onto the gold particles, forming a water-soluble gold cyanide complex. In simple terms, the solid gold disappears from the rock powder and becomes part of the liquid solution. All the other minerals and rock dust, which don't react with the cyanide, remain as solid particles. This process, called leaching, can take anywhere from 24 to 48 hours. It's a slow, patient chemical dance where the cyanide partner carefully selects the gold and whisks it away from the crowd of other minerals, leaving them behind. Once the gold has been dissolved into the solution, the next challenge is to get it out again. The most common method is called carbon in pulp. Small granules of activated carbon, which look a bit like black rice, are added to the slurry in the leaching tanks. This activated carbon has an amazing property. Gold is more attracted to it than it is to the cyanide solution. So, as the carbon granules mix with the slurry, the dissolved gold cyanide complex detaches from the water and sticks to the surface of the carbon. It's like using millions of tiny magnetic sponges to soak up the gold. After a while, the gold-loaded carbon granules are separated from the now worthless slurry using large screens. What's left is a pile of carbon rich with captured gold. But the gold is still not in its pure metallic form. The carbon is moved to a special vessel where it's washed with a hot, high-pressure caustic solution. This chemical bath forces the gold to release its bond with the carbon and go back into a new, highly concentrated solution. This final gold-rich liquid is called electrolytic solution, and it is now ready for the final step of turning the invisible, dissolved gold back into a solid metal. The concentrated gold-rich solution from the previous step is now ready for a process called electrowinning. The solution is pumped into special containers called electrolytic cells. Inside these cells are positive and negative terminals, known as anodes and cathodes. When a powerful electric current is passed through the solution, a bit like charging a giant battery, the gold is forced out of the solution and plates onto the negative terminals. Over several hours, a thick, sludgy layer of gold builds up on these cathodes. It doesn't look like much yet, more like dark brown mud than gleaming treasure. Once the process is complete, the steel wool cathodes, now heavy with gold sludge, are removed. They are sprayed with high-pressure water jets to wash off the crude gold. This sludge is then collected, filtered, and dried in an oven. The result is a gold-rich powder, but it's still not pure. It contains other metals that were collected along the way, like silver, copper, and zinc. To separate them, we need extreme heat. The gold powder is mixed with a special recipe of chemicals called flux. Now comes the most dramatic part, the smelting. The gold powder and flux mixture is placed into a crucible, a special pot made of materials like silicon carbide that can withstand incredible temperatures. The crucible is then placed inside a furnace. These furnaces can reach temperatures of over 1,200 degrees Celsius, about 2,200 degrees Fahrenheit. That's actually hotter than volcanic lava. Inside this inferno, the gold and other metals melt into a glowing liquid pool. The flux does its job binding with the impurities and causing them to rise to the surface, forming a layer of waste material called slag. Finally, the moment of truth. A smelter dressed in a silver, heat-reflective suit and face shield carefully tilts the crucible. The heavier molten gold is poured into a mold. The lighter slag is poured off separately. As the molten gold fills the mold, it glows with an intense, fiery light. It honestly looks like liquid sunshine. The mold is then left to cool. As it solidifies, it forms the first true bar of gold in our journey. This bar is called a d'or bar, from the French word for gilded. It's typically about 80% gold, but it's a solid, tangible product at last. The rough, raw material has been reborn in fire. The d'or bar from the mine site is a major achievement, but it's still a long way from being the kind of gold bar you'd find in a central bank vault. It's an alloy, a mixture of gold with other metals like silver and copper. To create an expensive investment-grade bar, this gold must be purified to an incredible standard. The d'or bars are securely transported to a specialized refinery. These are high-security facilities where the final, most delicate stages of purification take place. Here, the goal is to achieve a purity of 99.99%, often called 4 nines fine gold, or even higher for special cases. Upon arrival at the refinery, each d'or bar is carefully weighed and a small sample is drilled out and sent to the laboratory for assaying. This is a critical step to determine the exact gold content before refining begins. The most common and effective refining method used today is the Miller process. The d'or bars are remelted in a large crucible inside a furnace. A long clay pipe is then inserted into the molten metal, and a stream of pure chlorine gas is bubbled through it. The chlorine reacts with almost all the other metals like silver and copper, but not with the gold. As the chlorine gas bubbles through the molten mix, the impurities react to form metal chlorides. These chlorides are volatile and come off as fumes, which are safely collected, or they are less dense than the gold and rise to the surface as a liquid slag, which can be skimmed off. This process continues until only pure molten gold remains. The Miller process is fast and efficient, capable of producing gold with a purity of about 99.5%. This is very pure, but for the world's most expensive bars, we need to go one step further to get from good to perfect. To reach that coveted 99.99% purity, a second process is often used, the Wohlwill process. This is an electrolytic method similar to the electrowinning we saw earlier but much more precise. The 99.5% pure gold from the Miller process is cast into anodes and placed in a bath of chloroauric acid. A small, thin sheet of ultra-pure gold is used as the cathode. When an electric current is applied, the gold from the anode dissolves, travels through the acid solution, and plates, atom by atom, onto the pure gold cathode. Any remaining impurities fall to the bottom as a slime. This slow, careful process creates gold of exceptional purity. After the refining process, we finally have it. Gold of at least 99.99% purity. It exists as a gleaming molten liquid, ready to be shaped into its final iconic form. The creation of the world's most expensive gold bars is not just an industrial process, it's an art form. The most common method for creating high-quality bars is casting. The molten gold, at a precise temperature, is poured from the furnace's crucible into a preheated mold made of graphite or iron. These molds are precisely machined to create bars of a specific weight and dimension, most famously the 400 troy ounce, or about 12.4 kilogram, good delivery bar. The pour itself requires immense skill. The operator must pour the gold in a steady, continuous stream to avoid creating air bubbles or an uneven surface. It's a moment of intense focus, handling a liquid worth hundreds of thousands of dollars. As the gold fills the mold, its surface is often skimmed with a graphite rod to remove any last traces of dust or impurities. The bar is then left to cool under controlled conditions. If it cools too quickly, it can crack or develop internal stresses. If it cools too slowly, the crystal structure of the gold can be imperfect. The cooling process is managed carefully, sometimes with water jets, to ensure a solid, stable bar. While casting is common for large bars, smaller bars, especially those prized for their perfect finish, are often made differently. This method involves minting, similar to how coins are made. It starts with a continuous casting machine that produces a long, thin strip of pure gold with a perfect, uniform thickness. This gold ribbon is then fed into a high-tonnage stamping press. A blank, a piece of gold of the exact weight required, is punched out from the strip. This blank is then placed into another press where a die strikes it with immense force, imprinting it with intricate designs, logos, and lettering. This process creates bars with sharp edges and a mirror-like finish. Whether cast or minted, every single bar undergoes a rigorous quality control inspection. It is weighed on highly sensitive electronic scales to ensure it meets the exact weight specification. Its dimensions are measured with calipers and lasers. The surface is inspected under magnification for any flaws, scratches, or imperfections. Only the bars that are absolutely perfect will proceed to the final stage. This attention to detail is part of what makes these bars so expensive. It's not just the gold content. It's the guarantee of perfection in weight, purity, and craftsmanship that commands the highest price. A perfect, gleaming bar of pure gold is a beautiful thing, but without its credentials, it's just an anonymous piece of metal. What truly gives a gold bar its identity and guarantees its value is the hallmark. This is the final and one of the most crucial steps in its creation. After passing the final quality inspection, each bar is taken to a secure stamping station. Here, a series of official marks are permanently stamped or engraved onto its surface. This isn't just a decorative touch, it's the bar's passport, telling its entire story in a few small symbols. The first and most important mark is the refiner's stamp. This is the official logo or name of the refinery that produced the bar, such as Pamp Suisse, Valcambi, or the Royal Mint. This mark is a guarantee of the bar's origin and quality, backed by the reputation of the refiner. Next comes the purity stamp. This certifies the fineness of the gold, most commonly 999.9, indicating 99.99% purity. Then, the weight of the bar is stamped, for example, 400 troy ounces, or 1 kilogram. Finally, each bar is stamped with a unique serial number. This number is recorded in the refiner's ledger, making the bar fully traceable from its creation. For the world's most expensive and secure gold bars, the hallmarking goes even further. Many refineries now use advanced anti-counterfeiting technology. Pamp Suisse, for instance, has a technology called Veriscan. An intricate microscopic surface topography on the bar is scanned at the refinery, like a fingerprint. This digital fingerprint is stored in a database. Anyone with the Veriscan app can later scan the bar to instantly verify its authenticity. Other bars might include holographic security features, special inks, or laser-engraved microtext that is invisible to the naked eye. These features make counterfeiting a high-quality bar nearly impossible. Once hallmarked and verified, the bars are often encased in secure, tamper-evident packaging. This is especially common for smaller minted bars. The bar is sealed in a durable plastic card, known as a CertiCard or CertiPack. This packaging not only protects the bar's pristine surface, but also contains a printed certificate with the matching serial number and specifications. If the packaging is tampered with, it shows clear signs of damage, alerting a potential buyer that the bar's integrity may have been compromised. This final layer of security adds to the bar's value and provides peace of mind to the owner. The journey is complete. From a speck of dust inside a rock to a perfectly refined, hallmarked, and secured bar of pure gold. But the story doesn't end here. The final chapter is one of perpetual protection. These bars, representing immense wealth, must be kept safe. They are transported in armored vehicles under heavy guard to their final destinations, the world's most secure vaults. These are not your average bank safes. They are fortresses, often located deep underground, built to withstand almost any conceivable threat, from natural disasters to determined criminal attacks. Think of places like the Federal Reserve Bank of New York, which holds gold for numerous countries, or the legendary vaults at Fort Knox. These facilities are protected by layers upon layers of security. Massive steel doors weighing many tons seal the entrances. The walls are made of thick, steel-reinforced concrete. There are motion sensors, seismic detectors that can feel the slightest vibration, 24/7 video surveillance, and teams of highly trained armed guards. Access is strictly controlled through a series of checkpoints, requiring multiple keys, combinations, and biometric scans. No single person ever has all the information needed to open the vault. Inside these vaults, the gold bars are carefully stacked on shelves in numbered compartments. The environment is climate-controlled to prevent any possible degradation over time, though gold is incredibly stable. The bars just sit there, silent and still, a vast, concentrated store of wealth. Their value is tracked daily, fluctuating with the global markets, but their physical form remains constant. They are the ultimate financial backstop for governments and large financial institutions, a tangible asset in an increasingly digital world. They represent stability, security, and trust, and so our gleaming gold bar takes its place among thousands of others, a testament to an incredible journey. It is the culmination of geology, engineering, chemistry, and artistry. People treasure these bars not just for their monetary value, but for what they represent: permanence. In a world of constant change, gold endures. It's a physical embodiment of wealth that you can see and touch. Guarded deep within the earth, this expensive creation waits, a silent, shining symbol of humanity's timeless fascination with the ultimate treasure.